All right, so I'm going to share the screen here so you don't see me. Entire screen, share, it goes off into space. Okay. So today we're going to talk about a special group of variables called sequences. And we've talked about sequences a little bit up to this point in dealing with strings. Strings are really a type of sequence. But there's a few things that we can do with sequences that are unique to sequences. And so we're going to cover that material today. And sequences are powerful. They're really just groups of additional variables. In fact, one of the things that your book points out that I haven't pointed out yet in our discussions is that the material that we've covered up to this point in the book about different variables and different operations that you can do with the Python programming language pretty much encompass everything that a computer programming language needs to have. You could build off of all the information that you've had to create a complete program that does lots of things. But there's lots of other inputs and outputs and things to learn about. And one of those is this topic that we're going to talk about today, and that's the sequences. And so let's start talking about strings as a sequence and show kind of build on that. So remember that we can create a variable and set it equal to the value of a string, in this case George. And I have that value now. If I ask the computer to report that value, then it does. Print my name. So it's that variable that's stored, the character George. Okay, and the character is GEORGE. And we started to show that these are sequences last week when we used a for statement to loop through each of the characters in my name. That's easier to do from a command prompt, but I mean that's harder to do from a command prompt. It's easier to do when you define a function, but you actually can say for C in my name, press colon, and then type in print C, and then if you leave it blank, it'll do it. It'll run that little routine that you wrote. Not the most efficient or pretty way to do it, so I would usually write that as a script and then execute it rather than doing it right in the browser. I mean the interpreter, in the interactive environment. Okay, so one thing that we should note, and you probably, if you thought about it, probably thought about the fact that characters are actually just numbers themselves. A computer doesn't really have the ability to store anything besides a bunch of ones and zeros, and those ones and zeros can represent different things. We build on those basic ones and zeros to build larger numbers. And in fact, our method of reporting numbers is what we call a base 10 method. So the symbols that we've chosen for 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 are unique symbols. But after that point, we don't have any unique symbols for reporting a number that's larger than 10. Okay, the way that you report a number that's larger than 10, let's say 11, it's the very next number, is that it's one group of 10 and one group of one value. Okay, I know that is a basic principle that you probably learned a long time ago, back in 2nd or 3rd grade. But that number 11, we're saying, is 1 tens and 1 ones. Okay. Now with the computer, it actually stores everything instead of a base 10 system where after we get to 10, we start showing how many groups of 10 we have. The computer works by grouping together groups of 2. So it's because we really only have 0 and 1 values. So as soon as we get, we can count 0. Okay, 0 is an off, one single piece of information in the computer, which is called a bit. Okay, if that bit is off, we can say it's a 0, and if it's on, we could say it's a 1. So we can count to 1, but then we can say how many groups do we have. Okay? And so in a computer system, if we have 2 pieces of information, we could represent that by saying we have one group of 2 points. So that's how we would represent a 2. It becomes 1 in the 2's column and 0 in the 1's column. Okay, and then at that point, each additional number is just a power of 2. So we could represent this as being another power of 2. So we have one group of 2 to the 3rd. So, or sorry, 2 to the 2nd. So this would be 2 to the 0, 2 to the 1st, 2 to the 2nd, which would be 4. That's how we'd represent a 4. And we could represent a 16, okay, that way. So you can store any number between 0 and 16 by representing it as 4 numbers that are either 1 or 0, okay? And so on. Now, it's not this, how we represent numbers in this binary system isn't so important, except for the fact that this helps us to understand what the maximum possible value is that we can store in any particular number. So one of these values is a bit. So if we have a single bit to store, a single bit of information in order to store a number, we can really only store a 0 or a 1. Okay. If we have 2 bits of information, we can store a 0, a 1, or a 2. Okay. And then if we have 3 bits of information, we can store all the way up to 4, and so on for the powers of 2. And so with 8 bits, we can store 256 different values, 256 different unique values. And when we're dealing with strings, with characters, what's actually happening inside of the computer's brain is the computer is told this variable is a set of characters, and there's a table, a lookup table, that that ties a certain sequence of these numbers, 1 0 1 1 0, equals this character. For example, a character like A, okay, or B, or C, or D. And in fact, there's a unique code stored for uppercase and lowercase values. So there's enough in that 256 different character code set. There's enough to store uppercase and lowercase numbers, and also, any other special characters that we use, the and sign, the @ sign, any number that's on the keyboard. And there actually are a couple of different tables. So you can imagine these as being tables. Let me go to the internet for a second. If I typed in, probably the most common one, at least in the Western world, is ASCII character code. Okay. And this is just a table. I just Googled this. I should have come up with one before class. But you can see the character code for each of these numbers. So 0 all the way up to, I said 256, I'm sorry, 127. Okay. So we have 127 different values, okay, which is a power of 2 as well. Okay. All right. And then there really are 256 different options, but these in an 8-bit number, but those are called extended character codes. And so there's some additional things. But most of the characters you see on the keyboard are in these first 127. And And so a string is a representation of each of those. So it's a bunch of bits. It breaks down. It's a bunch of bits, but those bits are grouped into units of 8, and that's where we get the term byte. A byte is actually a group of 8 of these ones and zeros that can represent a number anywhere between 0 and 56. Okay, so that's actually like when somebody says I have a 24-bit display. What that means is that there's 24 bits. There's actually 8 bits that control the red color, 8 bits that control the blue color, and 8 bits that control the green color, RGB, and 8 bits is a byte. So there's 1 byte that controls each of those. So your computer screen is capable of producing 256 different types of red, 256 different types of blue, 256 different types of green. Okay, and so that's another way that everything boils down to these bits initial in the final. Finally, but before bits, we have bytes. Okay. All right. So if I go back to Python here, did I close that down? No, it's right there. Okay. So a string is just a series of these bytes, a string of bytes. So each of these G, E, O, R, G, and E is a byte that takes up exactly that amount of memory on disk. Takes up exactly 4 bits of information. I mean 8 bits of information. Okay, let's look at things that we can do besides what we already know. Let's create a new window and a new script to see what we can do with different characters, with different with things. So I'm gonna type in my name equals George. One of the functions that I can do with any sequence is I can ask that sequence how long it is. So this is a function that's built into Python that returns the length of a sequence. Yeah. So I'm going to save this, C, courses, week 3, example 1.5. All right, if I run that, it tells me that the length of that sequence is 6. There's 6 things in that sequence. And that can be useful for all sorts of things. For example, if I know that I'm going to store this information in a database, I might have a restriction on how many bytes that particular set of information is capable of holding. In other words, when I take this, if somebody's entered this into a form, or if somebody's entered this into a program like raw input, if they've entered my name and they enter a really long name, I might have to tell them my database doesn't support your 300 character name, and so I have the ability to inspect that. Later, when we talk about different types of lists, I might want to restrict, for example, the number of inputs. My sequence might be a list of raster data sets, and I might want to say, oh, you can only enter 5, and you've entered 6 different raster data sets. That's not valid. Okay. I may be more interested in just figuring out how long a process is going to take, and so before I enter a loop, I may want to know how many times through the loop is going to take, and I can report back to the user, oh, you've entered 300 data layers for me to go through. That might take a little while. Are you sure you want to continue? Things like that are great for getting the length. I mean, for using the length. All right. Actually, jumping back, I just noticed to the ASCII codes, there are other code sets for representing characters. One of those is called Unicode. There's all sorts of them, but ASCII is the most common. Okay, let's say that we want to take a sequence and we want to extract a certain item from a sequence. That we can do through a special way. Okay, let's say I want to get the very last letter in my name. I can say, here, I'll put a new line for this. Print my name. Actually, let's start with the very first letter. That's easier. Anytime I want to get a particular item out of a list, out of a sequence, any sequence, I can say my name, and then I put a bracket in Python. And then I give the index of that sequence, the index that the value appears in that sequence. And one thing to note is that in Python, sequences are numbered starting at 0. So 0 is the first element in a sequence. That might be a little bit hard to grasp at the start, but after a while, you just figure, oh, okay, I want the first element, that's 0. Second element is 2, and so on. Other than that, it doesn't skip any other values. It's just starting at 0. So if I run this, it should print the first element of that sequence, George, which is G. Sometimes when I'm looping through a particular set of values, I want to extract the first value in order to do something to initialize the loop. So that's something that's useful. All right. Another thing that I can do is to get any item in the data set. So if I get the third item in the sequence, run that, I get R, which is the third item. Oh, is it the third? Well, really it's the fourth, remember, because we're doing 0, 1, 2, 3. So if I say 3, I'm really getting the fourth. So I'm going to put a comment there. Gets the fourth item in the sequence. Comment this up. Say this one gets the first. This one gets the length. All right. Okay. So the next thing that we can do, we actually already talked about traversal with a for loop. So I'll skip that for now. We're going to show lots of examples in today's class because it becomes more and more useful for different things. The next thing on the list there is slices. We can slice up. I'm going to put my full name here. So I'm going to say this. We can slice up a sequence. We can ask it to return only a portion of the sequence. We can do that by putting in the first item that we want, and we put in where we want it to stop. So if we chose, let's say 5, let's see what this does. We want from index 0 to index 5. If we print this, we're going to get GEORG. Okay. Now G should be 0, 1, 2, 3, 4, and we said 5. So that's an interesting thing, is that when we do a slice of a list, the first number is inclusive in Python, but the last number is exclusive of that last number. So if we go from 0 to 5, we're excluding the fifth element. Okay, see, 0, 1, 2, 3, 4, 5. So we excluded George, which is really the fifth element there. So if we change this to 6, we'll get all of the first name. Okay. George. Okay. All right. So this gives us a slice. Now, all of these functions that we've talked about so far will work with every sequence that we're going to discuss today. All of these operations will work with all of the sequences. In fact, I've got one more to show. But before I do that, I'm just going to demonstrate that another advanced slicing technique. We can also slice something. We can leave off one of these. Okay, so we could say I want everything from 3 to the end. That's what that means. From 3 to the end. So if I run this guy, I'll get that. So I basically slice off the first 3 letters is what that's doing. And then vice versa, if I come in here and slice off the opposite, yeah, there's 8. So I'm going from the beginning to 8. Now, the second one isn't quite as useful because the beginning is always going to be 0. But in any case, it works. This is equivalent to this. Okay, but you don't always know where it's going to end. Okay. Beginning. So that's giving us a slice from the beginning to, I should say, to 8. And remember, the second number, even doing slices, it's exclusive of that second number. All right. So there's one other thing that I want to demonstrate that will apply to any function, and that's the in operator. The reason why I say it's an operator is because it'll work by giving a value and then saying in the name of the function. So I could say print, and I could say G in my name. Now what it's going to do, I don't know if I need parentheses here, but I'm going to run this anyway and see what happens. What it's going to do is see if the value G is inside of my name. It is. Okay. I can return that, and I don't have any F's in my name, so if I change this to F and ran it again, I would get false. See how it says false there at the bottom? I'm going to hide this. Okay, so that's the in operator. Okay. Now there are a couple more string operators that we want to talk about before we move on from strings. I've actually already introduced upper and lower, those functions. Okay, so upper and lower just takes a, I'll just demonstrate upper again. My name dot upper. Run, and I get the uppercase. Okay. Now, something that you may be wondering is that function. I didn't put my name inside of the parentheses. I didn't put my name in here. I put my name at the front and put dot. Okay. All right. So this gets into an important distinction. So some functions require parameters and they return a result. Some functions are actually built in to data types. And so this data type called a string has a function. And when a data type has a function attached to it, we call it a method. Okay? And when a data type itself has methods and has properties, we call that data type an object. Okay? That's a specific type of data. So strings are really objects, and objects can have information, like the information that's stored is George Raver, in quotes. Okay? It stores that string, but it also has some methods associated with it. And those methods that are associated with it are functions that will run on that object. Okay? Sometimes people like to think of, the reason why they're called objects is they behave a lot like real life things. We could start to conceptualize things that exist in the world, like a dog. Dogs exist in the world, right? And dogs have attributes. They have more than one attribute. A string really only has a single attribute, and that is the characters that represent it. But dogs could have an attribute name. Okay, maybe that's the only attribute they have in our simplification of the world. But they could also store other attributes like how tall they are, or how fast they can walk, or what color their hair is. And if we want to get an attribute out of a thing, so if I had an object called my dog, and it was a dog object, I might be able to say my dog dot color, okay, and that would give me the color. My dog dot age, and it would give me the age. Okay, these are examples without the parentheses. These would be examples of attributes of that dog object. Okay. Now, let's say we can't run this, obviously. My dog doesn't exist. Okay, I don't have a dog object, but I'm trying to show some examples. I could say my dog dot bark, and if I had an object that was a dog, that would be a method for the dog. It would bark, and I could say my dog dot eat, and that would be a method. There would be a function associated with those methods, or what we call those. Okay, and as we progress, we're gonna see things like inside of a GIS system, things like a data set, whether it's a raster data set or a vector data set, are going to have certain things we can do to those data. We've already interacted a little bit with the math one. I could show that as an example. So we've got that, I'll just put this up here. We've got that import math, okay? We call it a module, which it is, but it's also an object. And then we could say print math.py. That's an attribute of that of that module. And if we print math.py, it gives us what pi is. That was an example of an attribute. Okay. We've got another one, sqrt, that takes the square root of a number. Okay, and that's a method of that object. But that one still requires an input. So sometimes methods still require inputs. For example, if I was to build that dog object, I might say eat and then give it an amount to eat. Okay, that would be an example of something. It'd be up to me to write the code as to what it did. It might cause the dog object to increase in weight or something. Okay, as one of its attributes. All right, so that is that's a short. I'm sorry, maybe not a short explanation, but that was an explanation of what's going on here. This is a string object. A string is really an object. In fact, all of the sequences that we discussed today are really objects. And so a string dot the name of a function that's supported by that string. So upper is only supported for a string sequence. That's why I put it in this section. So they're upper and lower are both only supported for string functions. Okay. Replace is another one, which is very useful. Print my name dot replace, and we put the first, and we give it, replace takes two arguments. Okay. First, we give it what we want to replace. So we want to replace George with Georgia, maybe. Okay. So now if I run this, it's going to take George and replace George with Georgia. So it just swaps out any matches that it finds. So if you have a whole entire paragraph of text and you have it replace George with Georgia, it's going to replace every single instance of George with Georgia. Okay. So you could use it. The application for that is in a GIS setting, would be to replace everything in an attribute table with another value. Let's say all of a sudden you started calling something else, and you need to define that term and replace it. So that's what replace does. Is it searches through and finds those values and replaces them. Okay. The next one, find, is a little bit different. It does not replace it, but it tells you the index where it finds a certain value. So I could say, okay, find the value Raber, and it will find that value, and what it does is return the index. So you could see that 7 is the index. All right, so it found the index 7. What might be more useful is for it to actually find the space. Okay, so I can say find space, run. Now if I run this guy, it's going to tell me where the space is. So what if we had a list of a bunch of names and we wanted to sort them and create a new variable that had all the first names and another variable had all the last names? Well, we can do that really easily now. In fact, we could create a function last name, or yeah, let's just call it get last name. We got a function called get last name, and it's gonna take a string, and we'll just call the string input name. Okay, so it's gonna get a string called input name, and it's gonna return the last name. Okay, so the first thing that it needs to do is take the input name, and it's going to find, dot find, it's going to find the space. That's what this code is going to do. And since it's going to return that, anything that returns a variable, we can have that information stored in a variable. So I've got index, I'll just call it SP index, it stands for space index. So my space index is going to be the input name dot find. Okay. Next, what I'm going to do is have it return the input name, and then I'm going to slice it from the SP index to the end. And remember, I can do that by just leaving off the last character. So now it's going to return that. And the last thing to do is to modify this. There's an example of find here, so I'll take this one out. So the last thing to do is to print the results of my function, which is get last name, and I'm going to feed it my name. So now, when this function runs, it's going to return just my last name, hopefully. See if it works. It does. Now, it returns, it includes that space. If I didn't want it to include that space, it'd be an easy fix. Well, let's think about for a minute why it includes that space. Remember that when we get an index, it tells us where it is, and anytime we do a slice, it includes the starting index number, and it does not include the ending index number. So that's why it includes the space. If we wanted to exclude the space, we would simply turn SP index, and we'd say -1. Okay. I'll save, and we run this guy. Whoops, we run it, and whoops, that doesn't work. We have to go like this. That doesn't work for another reason that I didn't highlight. I will talk about that here in a second. Oh, it's actually +1, right? We're going the wrong direction. That should have worked. Sorry about that. +1. Okay, that's why it's always good to run your code and see if it works. +1, because -1 is going this way in the list. plus 1 would be moving this way. That's what we want to do. We want to make our number higher to get rid of that space. Okay. All right. It is possible here. Your book points this out. You may or may not find this useful, but I will include this option. You could use negative numbers in the index. This should give me everything but the very first number and the very last number. So if I run this guy and I print this, I get, that's this line right here, everything but the very first and the very last. So you can't express your indexes as, instead of expressing them as positive numbers, you're saying, when you use a negative number, you're saying from the right-hand side, count over this direction. So we're saying everything but the last number. So you can use negative numbers in slices. All right, so let's get back down to our function here where we used find to get just the last name. Well, this is nice and it works, okay? But the great thing about Python and lots of computer programming languages is actually sometimes when there's something very common that a particular function should do, there is a way to do it even faster that's built into the system. And the next one introduces the next concept, and that is the function called split. Okay, I did have equal equals in there, but we already know what equal equals does. Okay, I can take a string and I can split it. So I can say my name dot split. My name is actually a string function. So in Python, it's a little bit funny. You actually type in quote space quote, so that's a string, dot split, and then you give it the name of the string that you want to split. Oops, no, I was wrong. It's like JavaScript. I was getting confused. All right. Okay, so that's the code that you want to do. My name dot split, and then you give it a delimiter. A delimiter is the character that you want to eliminate and use to divide the string into two pieces. And you'll see that it is in fact divided those into two pieces. Now you'll see here some interesting notation. See, George is in quotes, there's this comma, and then Raber's in quotes, and then there's these brackets that go around the whole thing. This is actually the notation that is telling you that this is a particular type of thing. In fact, let's store this thing. Let's say, let's call it names. Names equals this. And we're going to print names still. But we're also going to print the type of names and see what data type this is. Okay, so I'm going to print the name still. And then I'm going to print the type of names to see what it is. All right, great. It says it's a type list. Okay, this is a list. Is it getting hot? You turn the lights on because it got dark. Just turn them. Yeah, that's good. I wanted to turn them on too. I was just waiting for a good break. Yeah. I can't see the keyboard right now. So thank you very much. And if it gets too hot, turn the air conditioner on. I think the people on the coast won't have a problem because I have the microphone. And hopefully I can project over the air conditioner. But anyway, we can see that the type of this object that got returned, this thing, I thought I plugged that in, is a list. The type of that thing is a list. And a list is another type of sequence. It's the next type of sequence. Okay. Lists are really cool sequences because unlike strings, lists can hold any other data type inside of them. So you can have a list of whatever you want. In fact, a list doesn't have to contain just strings. Okay, a list can be a mix. It can be mixed data types. So lists contain some strings and some numbers. A list can contain all numbers. It's just anything that you want to organize into a single entity becomes a list. So we can actually create our own lists. Okay, so I've separated this out, and we can access list. Before we create our own list, let's access this list. So we could say print names 0, and what's that going to do? By the way, so this is an index. We're asking for which element, the first element, the second element. When we say the first element, so this is going to print the first element of a list, which is the names. Okay. If I run this, it's going to print just George. That last thing is going to print George down at the bottom. See, it printed George. And if I wanted to print the second one, the last name, I could simply put 1 and say second. In fact, I could refer to that as last name. And so I could actually change this code so that it only had a single line that just said return. Well, I guess it wouldn't be a single line because I'd still have to do the split. So it doesn't simplify it that much, except for the fact that I could also, I thought I turned that off. I could also combine the two statements that I've made up to this point. Okay, that gets done by doing this. I could say print my name dot split, and then put the quotes, and then I could ask for the second name. I've negated the purpose for even having, whoops, the second name, for even having the function. So this line of code actually does what the function does. So this, let's review this. My name is a string that has a space in it. It's going to split that string where there's a space, and it's going to return that as a list. And then this code is going to return the second item in that list. Returns last name, second item in list, which was created by the split. Now this will print the last name, just Raber. Okay. So you can string together these statements. Okay. So if one statement returns a value that's a list, then you can treat that entire statement as a list, and then have it return numbers. Now this would fail, for example, if I didn't have a space. Now I'm going to get an error. The reason I'm going to get an error is it says that a list index is out of range. In fact, anytime you try to access a sequence using an index that doesn't exist, you're going to get an error that's going to look just almost like this. It depends on whether it's a list or one of the other types of sequences. Same thing, we could just say print my name 20 or 10. Oops. 20. And now it's going to say string index is out of range, but you're going to get an error that says index out of range whenever it doesn't whenever it doesn't work, or it doesn't have that problem. All right. We are going to, in the book, it talks about debugging kind of almost along the way. We are going to talk a little bit more about that next week when we look at, ways you can handle errors. Okay, but if you think about it, if you ever encountered this error, what you could do is, if you were searching through a bunch of strings that all had spaces in them, or you thought they had spaces in them, but all of a sudden you got to, Prince, singer guy, he only has one name, right? So he has, quote, it just said Prince with no spaces, okay? Then what you could do is you'd see, oh, I got an error, and then you'd look through your code and figure out why it failed. Oh, it failed because there's no space in his name. Then what you could do is use the find command to first find out if there was a space, and if there's not a space, you could write something to handle that. Maybe you would assign both the first name and the last name to be the same, or you just assign the last name to be, nothing, quote, quote, or the last name to be, the first name to be nothing, quote, quote, and the last name to be the only name. Okay. So there are ways, once you discover how your program is failing, there are several options. One option is to write your code so that it handles any possible error. And sometimes that's difficult because you don't anticipate what the error is going to be beforehand. But in simple programs, it's usually pretty straightforward. Like our program here, it'd be straightforward. Okay. The other option is to actually catch the error and tell the user there was an error, and we'll go over that. But that's not as useful because really Python already tells you that there's an error, and the only thing that you could do is report that error a little bit more graceful. You could say, I had an error somewhere in my code, sorry, and the user would know that it didn't work. But it's not as useful, but it does get used, and we'll discuss that later. Okay. So let's talk about creating our own lists. And at this point, I'm going to save this, and so this example will be up there. And I'm going to close this down and start a new window. And I'm going to say File, Save As, and this will be example 2. So I'll save it in C, courses, SPA, week 3, example 2.py. Save. Make this big. All right, at this point, maybe I'll start working on something that might be part of that is part of the lab assignment. And so I'll demonstrate to creating a list. Okay. So the way that we can create our own list is to just use the same notation that it used when it printed the list. And so if I wanted to create a list of, let's call this variable cities, I could do that by using the brackets. The brackets indicate that I'm going to create a list, and all my items are just separated by commas. And so I could create a list like this: Hattiesburg, comma, Mississippi, and then I'd say comma, and I could say New York, comma, NY, comma, Seattle. Oops, I forgot to put the quotes around it. Now in Python, remember I said that Python doesn't care if you use single quotes or double quotes as long as you're consistent. So something like this works. This is a string, this is a string, and this is a string. And I'll delete this later, but just to prove it to you, I could enter a number like 6. Not a city, but I'm just trying to show you that lists don't care what data you put in them. So if I say print cities here and I run this, it's a very simple program that's just going to create that list. And I can tell that these are strings because there's quotes around them. And I could tell that this is not a string because there's no quotes around it. It's just the number 6. Okay. All right. Okay. I skipped over the part that said lists are, sorry, I skipped over the part that says immutable versus mutable because I'm going to demonstrate what that means here. Okay. Strings are not what we call mutable. In fact, what mutable means is that we can change the values inside of them. So if I have a string and I'm going to call my string my name again, and I set that equal to George. If I wanted to, let's say I misspelled, well, yeah, let's just say I misspelled my name, George, okay? I misspelled it, and I wanted to replace this R with an E. I could do that, but not like this. My name, what's the index of that one? 0, 1, 2, 3, 4, 5. My name 5 equals E. Oh, E. You might think you could do that because this is the name of a variable, and this is the name. Then this is a value. So you might think, hey, I can take E and plug it in to this string. Nope, it doesn't work. A string object does not support item assignment, and that's exactly what being mutable means. Being mutable means that that particular sequence supports item assignment. You can assign it by item. So strings are not mutable. Okay, you can't change the value. If I want to change the value, I have to say, I have to like do a replace. A replace will work, but what a replace does, remember the myString.replace, it actually returns a new string where the values have changed. So it's important to remember that if you say myname.replace, you haven't changed the values in my name. You've simply taken the values from my name and created a new string where you've replaced those values. So you have to store those in a new number. So if I wanted to do what I wanted to do there, I can't do this. In fact, maybe I'll just leave this like this and say, work. So if I wanted to do that, I could say my name equals my name dot replace. I could do something like GR with GE. So now it will work if I print my name. Let's see how it changed that. And you might be saying, well, you did replace the 5th value in there. And in fact, you could do it more. I should do it more simply, more like that one. Where I could say something like 5, 0 through 5 plus E, like that. So this is going to do the same thing, but it does it without a replace. So I'm just replacing the very last. I'm doing it by index so that it's consistent with this. Okay. You might say, hey, you're replacing that. Well, I'm not. What I'm doing is creating a new value that's my name, the first 5 letters of my name plus an E, and I'm storing it back in. I'm writing over my name and storing it back in there. So that's what we mean by immutable. You can't replace the values in place. There's a way to get around it. This is the way to get around it, but you can't change those values in place. And with a list, you can. So I'm going to comment out this print statement just because I don't want it in there, but I'll leave the rest of the code there so you could run it later. Cities, I could say, hey, I want to take the last item, which is -1. Let's just first print that, see if it works. Print cities -1. Take the last item in cities. It's going to be 6. Okay. And instead of printing that item, let's replace that item. Equals I don't know how to spell Los Angeles. That's top of my head. It's going to equal my hometown. Fun. Okay. Oh, and then even though I've replaced it, I have to print it in order for you to see that it worked. So now, whoops, got to spell things right or Python will yell at me. Now if I run this, the last item became Irvine, California instead of 6. So I've got Hattiesburg, Mississippi, New York, Seattle, Washington, and Irvine, California. I've got those 4 values. Okay. Lists are mutable. We can adjust the value in lists, and that sometimes becomes useful. For example, what if we wanted to increment the value? Like we had a list of counts, counters, and for example, let's say we had a whole block of text, and we wanted to search that text and see how many A's were there, how many B's were there, how many C's were there, how many D's were there, and so on. And so what we could do is do a for loop for every character, see what it is, and then we could write some logic that would increment either the first item in the list, the second item in the list, or the third item in the list. And we could do that with a list, okay? Because lists can change their values. We could also do it with other data types that aren't mutable, but it would require a little more code to do it. And so you might ask, why are some things mutable and some things aren't? Basically, it boils down to the efficiency. Things that are not, it's not necessary to be mutable, you shouldn't make mutable because the program will be more efficient in the end. And then the other reason is because you may not ever want it to change. So if you make it a certain data type, if you write it in that data type, it'll return an error if it tries to change. If you actually wrote some bad code that changed the value, it'll return an error. Hey, you tried to change this value, but if it was a list and you try to change it, it would go ahead and change it, and you might not want to do that. And if you jump down a little bit in the outline, you'll see the next data type is called a tuple. A tuple is basically the exact same thing as a list. There's no difference except for tuples are mutable, lists are not mutable, okay? Or other way around. Lists are mutable, tuples are not mutable. They're like strings. You can't change the values in between. Okay, so lists are mutable. Then there's a number of list operations. So we have all the operations that we did before. We can slice lists. We can find the first item in the list, the second item in the list, the third item in the list. We can say the cities. We could say the second through the end, the first through the end, all those different things. We can use the in operator. Okay. I'm not sure. I haven't tried. I don't know if the find operator works. Let me see if it does, just for fun. But I didn't put that in there, but that would be a useful one to have. So let's print that. So I'm gonna print. Oh, spelled cities wrong. Thank you. Oops, still spelled it wrong. This is an experiment. It does not have that attribute find. We can't find an item in a list. Okay. We don't have that function. We could write it. We could write that function. It'd be pretty easy. In fact, we'll probably do that. Okay. So we do have all those other operations that we've talked about. The length. We can get the length of the cities. We'll run this. Find out all the items in our list. We can get the length. And we have to print it. Find out how many cities. So we could report, hey, there's 4 cities. Okay, in your list. There's a couple of nice ones, nice extra ones. These are called pop. Pop is interesting. Cities.pop it takes the first item in the list and returns it, but at a cost. Oops, I'm not really good at spelling this. In fact, one thing I'm going to do, so if I run this, it returned, sorry, it returns the last item of the list. So return the last item in the list, but at a cost of the item. So it's no longer in the list. It actually returns it to you and takes it out. See how it took it out? Now it's not in the list anymore. Okay. So if you want to create a list and you want to just go through every item in a list, you could do it using pop by removing those items in a loop, like a while loop. While the length is greater than 0, you could be popping out all the items and returning them. Okay. There's other ways to do that, but that's one way to do it. Okay, I'm going to comment that out because I don't want to pop it. Say removes last item and returns. So that's a function, okay, and it returns the value, but it also modifies the list itself. All right, cities.append takes an item and adds it to the list. So now we could do Dallas. Going all the way around. So what append does is it returns, I mean, it pushes an item into the list. I didn't print it. Should have printed it just to show you. That's not to say that it's not already in there. It's in there. It just, we didn't put it in there. So that's adding another item to the list, append. Remove is kind of like pop, but it removes the first occurrence of a specified value. So if we find Irvine, California, it'll remove it. All right, sort will sort a list. Default is that it sorts numbers first, and then it sorts character strings alphabetically. So if I just typed in cities.sort, spell it right, and then I print cities now, I will get the list sorted alphabetically. See that? I better put that up here. Now, unlike a string, like when I do string.upper, it's actually creating a new variable. But once I type cities.sort, it has actually changed the values in there. If I run this again, it's changed those values, and notice that there's actually no return value for that. It just sorts them in place. So this line doesn't do me any good. No, it's oh, I still have to have it. I still have to sort it, but it doesn't actually return a value. There we go. So now it's sorted that list, and it makes it permanent. It changed the list. So if there's a reason that you need to create a list and then sort it, but you need to keep the original list that's unsorted, you should make a copy. Okay. Let's see how we would make a copy. So first of all, let's create a copy called cities unsort equals cities. Let's see if this works. Print cities unsort. Run this guy. Oh, look at what it did. Okay, it created that list, but now both lists are sorted. Okay, and I'll try to explain now why both lists are sorted. Basically, what happens is if we use the equal sign for an object that is mutable, what it does is it just labels that box with two different labels. So now that box has the label cities, and that box has the label, the place in memory has the label cities unsorted. So it's the same thing in memory. Okay. So lists, because they're mutable, when it tries to get to that point in the computer, it sees the list that's been sorted. So the problem is that we need to actually make a copy in memory. Let's do something like this. Right? So this is just Python specific gymnastics that has to be done. So there are other computer languages that do this. Sometimes it's more explicit, like you say this is actually a pointer, or this is an actual name of that actual space in memory. Okay, so by doing this, what we've done is we've used a slice, which is really a function, and we've sliced from the beginning to the end. And so in slicing, we created a copy. Okay? So if you do have a situation where you want to store the original, and this will get you might get to see this later on in the course, when you ask for a particular variable and you want to do something to it and you change it, you might say, well, why did it change it in this copy? Well, it's because it's looking at the same place, the same instance. Okay. All right. Another place that it would be a gotcha is if you fed a list into a function and you did something to that list inside the function. Normally, when you feed something into a function, remember we said anything that happens in the function stays in the function earlier. Well, that's only true with these raw data types and things that are mutable. Things that aren't mutable, things that aren't mutable. That's only true with things that aren't mutable. Things that are mutable, they'll modify themselves in the list. In the function. All right. So this is the code that you would do to make a copy of a list. That makes a copy of the list. If you don't do that, it's going to sort. Well, it's not that it's sorting both. It's just that you've given the same name to two different things. It's kind of like if I had a dog and I gave that dog the variable my dog, but then I also gave it the variable name my puppy. Okay, it has two different names, and I said my puppy dot bark. Well, it wouldn't bark twice, but both of those things would run. Not both, but that single thing would run that function. Okay, so that's sort. Join is kind of the opposite of split. This will be a silly example, but you could. I'm gonna comment this out for now. Say print cities dot join. Actually, this is. I have to go like this. You give it the delimiter. That's where I got confused earlier. You give it the delimiter and you say dot join and you give it the list. Now we'll run this guy and notice that what it's created here is a long string. This is a long string where the delimiter is the spaces. Now, what if I wanted to put additional spaces in there? I could just make the delimiter bigger. And this guy, and now I have more spaces in between there. Okay. In fact, I could even do something like this. Remember from the first week, just go like this and say times 5. So it would perform this first, then do the join based on that. So that works as well. All right, let's see. Okay, so I'm going to write a function that's going up here at the top. I'm going to write a function that's going to go take a list. And actually, what I'm going to do here, save this, and then I'm going to create a new one, example 3. We're going to come back to that because we're going to use that one. Recent file or recent files. Oops, new window. And so I'm going to create a function that takes a list. Okay, and this is also going to be part of the lab. Okay. Eventually, this function is going to find the average of all the values in a list. Okay. Right now, first of all, it's just going to do a for statement for item. For value, I'll do value in input list and value. I mean, eventually, I gotta give it a list, input list. Subbing out this this code that's going to create a mean. Right? So I gotta create a list. Going to have a bunch of values in it that are going to be numbers. You don't have to have the same numbers as me, but that, oh, I need an equal sign. This code here takes a list of numbers and creates a list of numbers. Creates a list of numbers, and then this code will run my function, which eventually will find the average value of those functions. Okay, so find mean, I'm going to give it my list and run this guy. Oh, I got to save this. So let's save it in the example folder, courses, SPA. Week 3, call it example 3.py. But printed each item in the list. Okay, it's not a very useful list so far. But I want to demonstrate a few things because eventually it's going to find the mean. But before I do that, I'm going to demonstrate that if I do something like this. Value equals value plus 1. And my list. I'll run this again. Okay. Notice that those values didn't change. See how that did not change? The reason that they didn't change is because value is, even though lists are mutable, value is a variable, and it's this for statement. When we do a for statement with the list, it's actually taking the value out of the list and putting it in a new variable for you. So if you modify that, it doesn't change it. Okay. However, if we did something like this inside the list, and we said input list, and we changed the first item in the list to 44, that is going to cause a change. Okay. So that causes a change in the list. So if we actually ask for the values in the list to be changed, it will change them. Okay. But if we just think we're adding 1 to them, we're not. In fact, if we wanted to actually add 1 to them, we would have to go like this and say input list, and then give the index, which we don't have at this point, and say equal to value. How could we get the index? Think of a way we can get that? I don't want to do this anymore. Is there a way to get the index? because right now value gives us the actual value, right? Value gives us the number, but it makes a copy of it, okay? It's storing, when I say the actual value, I mean that it's giving us the value rather than a reference to the location of that value. All right, since nobody's commented so far, I'll go ahead and say, what if I went like this? We did this last week. Count equals 0, and at the end of the for statement, I said count equals count plus 1. Okay, that's going to give us a counter that will always increase, and it will tell us what the value. It'll tell us what the index is for that particular item in the loop. So now if I run this, it will actually be reassigning those values. So notice it was 23, 4, 32. Those have all increased by 1. See that? They've increased by 1. In fact, I can go like this, go like this at this point. There we go. So each of these values have been increased by 1. That's not really what we want to do. We want to find the mean. Okay? But we've demonstrated an important principle that we can count up something inside of a loop, which we did show last week. All right, what is the mean, by the way? We want to find the average, not talking about programming, if we want to find the average value, if we want to find the average of a list of numbers, not a Python list, but just any list of numbers, how do we do that? What's the process for finding the mean of a list of numbers?
The total of the values divided by the number of values.
Exactly, the total number of values divided by the number of values. One thing that's interesting is that we've already calculated the number of values in our script, but we didn't really have to do that. Why didn't we have to calculate the list? I mean, the number of values. There's a Python. There's a Pythonic way to do that. Okay, we can just ask for the length of a list and it'll give it to us. But incidentally, if I was to say print count, comma, the length of the input list and run this guy, those numbers are actually the same. See, it said print 6, 6. So we don't have to store this number, but it's okay that we did. That's one way to store the count, the number of values. Okay, we store the number of values that way. I'm going to delete this other code because we don't really need it. Okay, so we need to find a way to store the sum, which we actually already did as part of a lab last week. So remember, we're calculating up the total number of the total distance along that line. Okay, and the way that we did that, if you remember, is to just create a variable. I'm going to change the variable name to total. I'll just call it total and say total equals total plus value and say total here. So now total will give me the sum. It's basically just the way to implement a sum. I'm by the way, if you're looking at the outline, I'm skipping over tuples for a second, okay? And because really they're the same as lists, there's just a few little differences. And I went down to sequencing skills, and right now we're doing what's called creating a reduce function. Okay, a reduce function is any function that takes a list and summarizes that list into a single value. And it could also take a tuple. We haven't covered tuples yet, but tuples are really lists that can't be changed. Okay, so a reduce function, all it does is take it's a function that takes it takes a sequence as an input, and the output is a single value. Okay, the input is a sequence, the output's a single value. That's a reduce function. So we've created a reduce function almost. All we'd have to do is say return total. So our reduce function, now, if I say print, I'm going to change this from printing my list because I don't really care about the list anymore. I'm doing a reduce function, and I create my function, and my reduce function takes a list and it turns it into a single number. What is the single number that it's turned into? 6034. What does that represent, though? I called my function find means, so it's a clue. We want to calculate the mean, but have we calculated the mean? What number have we calculated? 6034. What does that number represent? Looking at the code, maybe we need to look at this function a little bit better then. Okay, so a for loop that has the name of a variable on a list does what? It looks at it creates a loop, and every time through the loop, what's the value of this variable we call value going to be? The first time through the loop, what's the value of value? Anybody? What's that? This is going to take a list. So this is the list that's coming in. Okay. This list goes into the function, and when it goes into the function, and I run this, input list is going to be this list right here. So the first time through, let's just print it. Let's just print it then. Okay. I'm going to print value. Again. So this is the first time through the loop. Okay, the value was 23. In fact, I can print this. I'm going to print. I'll go back to having count there. Count equals 0, and I'm going to print count and print the value. And I'm going to have to increment count. Count equals count plus 1. I'm going to run this, and you can see the first time through, which remember everything's 0 based. First time through it's 23. The second time through it's 4. Third time through it's 32. And that's because this list is 23, 4, 32, 56, then this really high number, 456, and so on. Okay. I don't really need it to do this, so I'm going to take this out. Oh, yeah. Take that out, take that out. You see, each time through the loop, the value of this variable called value, the first time through the loop, it's the first element in the list. The second time through the loop, it's the second element in the list. The third time through the loop, it's the third element in the list, and so on. So I'm going to ask again here, the first time through the loop, what is the value of value? Second time through the list, 4. Good. Yep. I might have used these numbers once, but yeah, it's 4. Third time through, 32, and so on. So what happens when we get to here? The first time through, what's the value of total? First time through the list. Yes, the first time through the loop, the value of total is 0. 0 plus 23 is 23. So the value 23 gets reassigned, and total becomes 23 instead of being 0. All right, now let's look at the second time through the loop. The second time through the loop, total becomes a new value that that is the addition of total. And what's total the second time through the loop? We just established 23, because 23 plus 0 is 23. Now what's value the second time through the loop? 4. So what's 23 plus 4? 27. Exactly. So now the total has the value of 27. Okay, and we go through again. So now total is going to have a value of 27, plus value will have a value of 32 this time. And so we get 32 plus 27 is, I don't know, 59. And then it continues on like that. And so at the end, what we're going to get is the total. But the reason why I called it total is it's not magic. If I called it you know, my number, it would still be the total. Okay, the magic is in the code, not the name of the variable. So when I say return total, I'm returning that number. Okay, so this represents the total, or another way to say that mathematically is the sum. Okay, so right now our reduce function returns the sum of all of those values in the list. Okay. If I want to turn that into a mean, I could simply do this: the length of the input list. Okay. So now, instead of returning the total, I'm returning the total divided by the length, which the length should be the number of values, and we already established that that's the mean. So if I run this, I'm going to get a value, and I'm gonna take this statement out right now because I don't need it. I'm gonna run it, and I get 1005. Now, that may or may not be right. Remember, Python sometimes will do rounding for you if you don't explicitly tell it that you want your values as floats. So I'm going to do that. I'm going to change these values to floats before I do the division. And that way, if there's any remainder, it'll report it. And in fact, that was a good idea that I did that, okay? Because it didn't actually round, it just truncated it. So if you want to get the exact number, turn your numbers into floats. The nice thing about that is even if your list already had float values in it, like if I change this to 0.6, if you convert a float to a float, it doesn't hurt anything. It's not going to report an error. It's just it's just going to continue on with the program. Okay. So remember, floating points allow decimals. Non-floating points don't, or integers don't allow that. Okay. Change this back. File save. All right. So that is a function that will find the mean. And you could also have a function that would calculate the total or the sum. That's what we talked about. We skipped over a function that could count occurrences. Okay? That would just involve a little bit of logic. Like you could count the number of times. Let's just write a new function. It does the same thing, except not the exact same thing. We're going to write a function, and this is still a reduce function. It's just a specific type of reduce function. I'm going to copy and paste it and say count large. Okay. So now I'm writing a function that's going to count large numbers, and it's still going to take the same input list. I'm going to delete this here, delete it out of there too, because I really don't want it to do that. Okay. Now my goal is to count large numbers. Well, what's a large number? Who knows? Let's let the user decide what the large number is. Okay. So I'm going to say the input list and the large number. And I want to return to the user all of those items in the list that are larger than the value large number. How do I express that? I could do something like this, right? So total is going to be equal to 0 because I'm still going to, total now is going to be just the number of times that it was larger. Okay. This is going to require an if statement. The if statement is going to look like this. If, and then I'm going to say value is less than, or I said greater than. How many large numbers are there? Large number. Then total is going to be equal to the total plus 1, because we're just going to count them up. So now if I look through what this function does, I'm going to put a space here so I get a little bit of breathing room there. In fact, I'm going to put a little comment. This function calculates total number of large numbers as defined by user. This function finds the average value of a list or tuple. In fact, it'll work for a tuple. So one of the great things is that since they're sequences, if all of your code works on either type, then it'll work for either type. Okay. All right. Okay. So I'm also going to print, in addition to printing the list, I'm going to print the count large. Say count large, and then I'm going to feed it my list, but now I'm going to feed it a number like I'll say 100 is a large number. Anything over 100, that's a large number. And so what should happen is that this little simple function here should return the total large numbers, which are numbers over 100. And you can see that that's what it did. See, it printed out 2, and there are in fact 2 numbers over 100. If I modified this and changed this value to 10 and said 10 was a large number, I'm going to get a new function. I'm going to get a new value out of that function of 5. There are 5 values, 1, 2, 3, 4, 5 that are over 10. I'll leave that as 100 for now. Okay. I'll say. All right. So that's a counting function, which is really a specific type of reduce function. Reduce functions, like I said, are functions that return a single value from a list. They take a list and they reduce it down, or a tuple. They take a sequence and they reduce it down to a single number. So that's a skill that's important to have, is the ability to write reduce functions. And they all involve loops. In fact, each of these types of functions that we're going to talk about involve looping over the functions. Okay. All right. And we could have a function that took a string and counted how many G's there were in the string. That would be another example of a reduce function, but it would be doing something slightly different. Let's see what time it is here. Okay. Okay. Let's cover map function and a filter function, and then we'll take a break. I actually added dictionaries on here at the last minute. We may leave that to next week, depending on how much time we have. But we will introduce the topic during the lab portion. Okay. So a map function. A map function, instead of returning a single value, a map function takes the values in a sequence and modifies those values if we're talking about a list, or it could return a whole separate, a new list that has modified values in it. Okay. Or a new tuple that has modified values in it. So let's do that. Let's call. There's already a function that does this, but no, actually there isn't a function that does this for a list. So let's say squared. I'm going to call it square list. Okay, and it's going to take an input list, and it's going to return input list. In fact, we actually, if this is a list, we don't actually need to do this. We don't need to return input list. But we could just say for value in input list, we could say you have to get the count because we're going to have to get the index. For count equals 0. Say count equals count plus 1. And then we'd say input list count equals how do we get the square? We could just go value times value. All right. So we run this, and whoops, before I run it, I'm going to actually print. I don't have to print it. We'll modify this so that it performs a little differently in a second. In fact, I'm going to call this square list in place, or rename the function that. So now we're calling this square list in place, and we're going to run that and then print my list. So now if I run it, so I've created a little function that's going to, notice this line of code right here, I'm going to reset the value of this list equal to value times value. Okay. Another way to write this that would work too is this. Remember, we talked about that first week or two of class. This does an exponent. It's the same way to write the same thing. We run this, and now look what's happened. Each of those items got squared, but they got squared in place. So now my list has been permanently altered. Okay, that may or may not be desirable. In fact, usually most people that if they're going to use your function later, they might not like that. Okay, so let's modify this so that it actually just creates a new list. Now it's just going to square a list. Instead of modifying it in place, it's going to create, we're going to create an output list. That has nothing in it. So this is an empty output list. And then we're going to, we don't even have to count it anymore. We're just going to do like this. Out. Remember, we talked about this function, output append. What append is going to do is take the values in output list and square them. So we'll just say value. Okay. Now we do have to return output list. So this time it goes into the function, input list goes into the function, but instead of writing over it like we did here, writing over each of the individual values, we created a new list and we're adding the items from the old list, but we're squaring them and putting them into the new list, output list, and returning that output list. So now I can actually say print output list and give it my list. Okay, so now if I run this, this doesn't change the input list. Let's see what, oh, I need an equal sign there. Right there. Oh, it's time to take a break because I'm getting, yeah. So I need to put the name of the function there. Now this will work. All right. Now, let's comment out square list because we don't want that anymore. Huh. This is interesting. Where did it square these values? I am not sure exactly why this is returning. Oh, yeah. Sorry. There's nothing wrong with this. It was working as I expected. I was just thinking too hard. Again, I think I need to take a break. Okay, so it's printing the squared list, which should be the squared of all the values. That's a different list than my list. It didn't change the values in place this time. So I've got both examples here. So this squares the values in place and modifies the list. This creates a new list and slowly adds those, not slowly, does it really fast, adds those values in. Okay, so that's a map function. A filter function does the same thing, except for instead of changing the values, it removes those values from the list or modifies those values in the list depending on an if statement. Okay, so you could put a statement in here, a filter function, that would, if the values were too high, the values were over 5, make the value 5. Or if the values were over 100, make the values 100. That would be an example of a filter. A filter function. So a filter function, a map function returns always exactly the same amount of values that were in the input sequence. So a map function takes a sequence and returns those sequences modified somehow. Okay, it squares them, it adds them together, whatnot. A filter function can return less values, can return only those values that meet a certain criteria. Okay, so here, let's take the squared list one. This will be the last one we do, like I said, before the break. And we'll say return, call it return large instead of count large. Okay, so our output list is only going to be, we're also going to have to feed it a value, a large number value. Got our large number there. And we're only going to do this append if it meets the criteria. If value is greater than large number, then append it. But we're not going to square it this time. So now it's returning only those values that are large. Oops. So let's test this function, and then we'll take our break. Print return large, and then input, or my list. That's the name of the function outside of the my list, and my large number is going to be 100. It's only going to return those lists. I mean, it's only going to put in the return list those values that are larger than 100. Messed up. I need a colon, and I need a space there. Run. Okay, so I get those values, 23, 4, 32, 56. Those values that were over 100 are just those two values. So this is a filter function. So I'm going to return, I'm going to say filter function that returns a list of values over input, user input. Okay. So that's what that function does. Okay. All right. So each of those functions, that's an example of, we covered totals, covered means, we covered counting. We didn't cover standard deviation, but we'll talk about what that means in the lab. Okay, standard deviation is another number that can be calculated on a list of numbers. We talked about map functions. There's a map function here that we use the term map in geography to mean, you know, a spatial thing. But here we're talking about map meaning a path for the numbers to flow through. So in this case, we squared all the numbers. So that's what a map function does. It performs a specific operation on each function, and then a filter function. Now there are shortcuts actually for writing simple map functions and simple filter functions in Python, which we're not going to cover in this class. But writing general map functions still requires this skill that we've discussed. We'll leave it there. I don't know if we'll cover those special functions unless there's a need to cover them in the lab. The range function is actually, let's just do that real quick. Range is a function that will return a list from a starting and ending point. So if I say range 3 comma 5, print. What happened? Print. I think I print. I cut and pasted something by accident. Range 3 comma, I'll go 20. What it does is it just creates a list for you that is numbers that start at 3 and go all the way almost to the number right before the top number. Okay, so if you wanted to create a simple list of values, you could do that. So that's useful for, let's say, in a for statement, you could say for x in range 3 to 20, then you would always go through there. In fact, what we will use it for in this course is what if you wanted to iterate through the months of the year, but the months of the year were coded 1 to 12. You could say for a month in range 1 comma 13, and your list would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so let's say you had file names, and that's exactly what we're going to do. File names that represented data sets of each month of the year. Then you could use that function. All right, let's go ahead. What time is it? It is about 7 minutes to 7. Let's go ahead and take a 15-minute break and come back approximately 10 minutes after the hour and discuss the lab and how we're gonna solve the problems in the lab. And as part of that, I will introduce this concept of a dictionary, but I'll get heavier into that next week because we don't have time to discuss everything about dictionaries today. Okay, so I'm going to go ahead and stop this thing, and I'll go ahead and stop the broadcast.